Module 6.7, Square Roots and Pythagorean Theorem. So in this lecture video, I'm going to explain to you how to calculate square roots. All right. So another word for square root is actually called the radical. And I will introduce this word radical in Module 15 of Math 108. So basically, radical is basically anything got something to do with roots, because I can have a square root, I can have a cube roots or fourth roots. Okay, there's no first roots. Okay, the smallest one I have is actually a square root. So here are the perfect square numbers from 1 through 20. All right, some of y'all probably already remember this already. All right, so we're gonna learn a lot more about radicals in module 15, but here I'm just gonna kind of mention a couple wordings. So the radical sign is basically your root, square root, cube root, so on and so forth. All right, the number that's inside the square root, whatever is inside the square root, is called a radicand. Okay, so so if I have a square root of 49, the complete expression for square root of 29 is called the radical or radical expression. All right. So what's the big deal about radical or square roots? Because in math, all the operation has its inverse or opposite operation, just like add and subtract are opposite to each other, multiply and divide are opposite together. So basically now the squares in square root are actually opposite operation. So what's the big deal about being opposite operation? Well, since they are opposite operation, they actually cancel each other out, kind of like. Just like this square root of 49. All right. So if you type in square root of 49 in the calculator, it's going to be 7. Just like right here, I copied this from the textbook. This is all the square roots. Okay. Basically, where the answer is from 1 through 20, just opposite of what's up here. So basically, what I mean by they cancel each other is, basically 49 can be rewritten as 7 squared. So since square and square roots are opposite operation, they actually cancel each other out. So the only thing I have left with is simply 7. Okay, so this is one way you can look at it. All right, so let's try some of these problems. Determine whether or not the indicated number is a perfect square. So if you know your multiplication table very well, you know 45 is not a perfect square number, okay? Because 45 is somewhere between 36 and 39, okay, which is 6 squared or 7 squared. So 45 being caught somewhere in between, that make them not a perfect square number. So what's the big deal about not being a perfect square number? Well, anything that is not a perfect square number, and when we take a square root of them, they become what we so-call the irrational number, which I will write it down or explain this definition a little bit better in Module 8. Irrational numbers are basically is a number where it got a bunch of decimal places, okay, where the decimal places does not have any repeating pattern where we can convert them back into a fraction. So because from module 3 we noticed that even though some fraction, once we divide them, where the decimal places never end, because of its repeating pattern on the decimal places, they are able to convert back into some sort of fraction. So those are called the rational numbers. Okay. So if I was a second square root of this 45 right here, my answer is 6.7 something. So if you look at this decimal places, it actually never ends. It keep on going forever, and the decimal places has no repeating pattern whatsoever. So that means number like these, called the irrational number, can never convert back to a fraction. Okay, calculator would never do this for me. All right, that's called the irrational number. So when numbers are not perfect square and I'm trying to take a square root of it, all I'm getting is a bunch of crazy decimals, okay, called the irrational numbers. All right, evaluate the following expression. All right, so for module 4, I show you how to do exponents, so 12 squared, or you can look at the table above. 12 squared, 12 caret key to the second power, that will be 144. All right, if you have to take Math 108, I do recommend students begin to memorize the perfect square number from 1 through 15. Okay, those are the ones that we encounter the most. All right, find the value of the indicated square root. So 361. So let's see. I don't know what it is. Second square root 361. All right, it's 19. So that's 9. So 361 must be 19 squared. So the square root of it, 361, is 19. Now 0.04. But as a matter of fact, if you just think about this number 4 here, 4 is a perfect square. So square root of 0.04 got to also be a perfect square number, because I'm thinking 0.2 times 0.2 is going to be 0.04. So my answer got to be 0.02. Opposite operation. So second square root, 0.04. I just want to make sure I show you how to do this in the calculator. My answer is 0.2. All right, 13 is not a perfect square number. So when I take a square root, okay, it's going to give me some kind of crazy decimal. So let's estimate the radical by identify which two consecutive integer is fall in between. So think about this, okay? 13. Give me a perfect square number that's between 13. Okay? Perfect square before 13 and one after 13. So the one after 13 got to be square root of 16, which is 4. All right? So before 13, the previous perfect square number before 13 got to be 9. So square root of 9 is 3. So square root of 13, whatever this answer is, got to be between what? 3 and 4. Okay, that's what I mean. So if I were typing square root of 13, this is going to give me 3 point something, which is between 3 and 4. All right, this is an example. Find the value of the indicated square root. Run my answer to 3 decimal places. So let's see. Square root of 335. 3 decimal place, that will be 18.303. So in this lecture video, I do want to show you, want to talk about what a square root are, or what's or the word radical, what they are, and begin to get you thinking about the perfect square numbers and the way how we key in these square root as well. So the next lecture video will begin talk about Pythagorean Theorem, because it turns out numbers such as the square root thing, where we end up with sometimes we end up with these decimal places that can never convert to a fraction. It's basically the radical. The idea of a radical expression or square root was actually discovered accidentally by a student of Pythagoras, okay, when they actually working through Pythagorean Theorem. All right, so we'll talk about Pythagorean Theorem in the next lecture video. All right, thank you for watching.